Hello everyone and welcome back to the tutorial series. In this part of the tutorial, we will go over all the pricing details with regards to all the products used in the project that was created from this tutorial. Since Unreal Engine is free to use and only incurs a 5% royalty fee when your published game starts generating a lifetime gross revenue of more than $1 million, the only immediate cost from this tutorial will come from the various AWS services used throughout the tutorial series, which include GameLift, API Gateway, Lambda, Dynamodb, Cognito, SNS, and Cloudwatch. In this video, we will go over the general prices and costs for each of the AWS services just mentioned, as well as how much and how long you can use each AWS service for free before you have to actually start paying for the service to continue utilizing it. As always, before we begin, if you want to support the channel, then please consider supporting us by becoming a patron on Patreon, donating to us via PayPal, or becoming a GitHub sponsor. Links to those will all be in the description below, and with all of that said, let's get started. So first, go ahead and open up the AWS Management Console in the web browser of your choice. Link will be in the description below. Make sure you are signed into your AWS account, and from here proceed to where your username is on the top right corner. Click on it and select My Billing Dashboard, and that should take you to the Billing and Cost Management Dashboard. This dashboard is where you do everything related to billing and cost management with regards to any AWS service used in any region on the account that you are currently signed into. So even though in the URL, as you will see throughout this video, in various AWS Billing Console pages, there is a URL query parameter called region. Just ignore it because the billing and cost data used in this dashboard comprises of all the data for all AWS services for all regions. That's why it says up here on the top right corner to the right of your username, the word global instead of one specific region. This dashboard is where you go to in order to manage your payment methods, set up billing alerts, as well as monitor, analyze, and better understand your costs and usage over a period of time in specific regions. I am not going to go over every single tool or feature provided by AWS Billing and Cost Management that you see on the left side of the screen. However, I will go over what I believe to be are the features that you should know and get yourself to be familiar with. Starting with what we are looking at now, the home page. So here you can see under where it says Spend Summary on the left, from left to right on this bar graph, how much you were charged last month, how much you will be charged in your next billing statement based on the costs accumulated so far this month to date for using AWS services, and the projected amount that you will spend for the whole month, which is calculated by AWS using some formula. Note that the middle metric in this graph, the month-to-date spending, is not updated in real time. I'm not exactly sure how often it gets updated, but keep in mind that the month-to-date spending in this graph is usually not reflective of your current total spending for this month, since it may be delayed by a day or two or more. Therefore, whatever this number ends up being on the last day of the month may not necessarily be how much you get charged for this month, because it may not take into account data from the last day or two or more of the month. And under where it says month to date spend by service on the right, you would normally see a pie chart that shows you the proportion of how much you have spent so far this month to date for each AWS service you have used. Right now on my screen, it's an empty chart because luckily all my AWS service usage has not gone over the free tier limit yet for this month. So I don't owe anything, hence why it says for me down here, no amount due. This pie chart will look differently for you on your screen right now if you have used AWS services over the free tier limit, or you have used AWS services in ways that are not free tier eligible. We will talk more about the free tier later in this video, but if we scroll down a little bit under where it says top free tier services by usage, you will actually see that there is a table that tracks your free tier usage for each AWS service. On the home page, it will be limited to the top 5 services and service measurements for this month. But if we click on the View All button on the top right corner of this table, that will take us to the full chart containing the progress towards the AWS free tier usage limit for every AWS service measurement applicable for this month. So what do I mean by AWS service measurement? Well, as you can see, there can be more than one entry in this table for each AWS service, because when you use an AWS service, you are charged for that service for multiple reasons based on different metrics. For example, on my screen, the second entry at the top is for the AWS Lambda service, specifically the 1 million free requests per month service measurement. And then the other columns in this row tell you how far along you are in terms of hitting that free tier limit currently and forecasted numbers wise and percentage wise. But if we go down to the fourth to last entry in this table, we see another entry for the AWS Lambda service, but for the free 400,000 seconds of compute time per month service measurement. And the other columns in this row are similar across all entries in this table. The point is that for each AWS service, you are charged based on a variety of metrics, not just one. Also, another thing to keep in mind is that I still don't know why, but GameLift C5.large EC2 instance usage is not tracked in this table, even though it does qualify under the free tier. In addition to that, although I did not mention the key management and simple queue services at the beginning of this video, they can be seen in this chart, and I'm not sure if it is something that I am doing outside of the tutorial that is incurring usage for these two AWS services, but as far as I know, I never touched the key management and simple queue services throughout this tutorial, so I will not cover the pricing for those two services in this video, but I will have some links in the description covering the cost for those services, just in case the tutorial did use those services indirectly. Moving on to the rest of the billing and cost management dashboard. So on the left side, starting from the bottom up, again, I'm just going to go over what I believe is the most important, especially for beginners. So under where it says preferences, you will see where it says payment methods. So if you click on that, that will take you to a page where you set your payment methods. Right above that are your billing preferences. So if I click that, you will see a small page with a few options that you can enable or disable. The first one is whether or not you want to receive your invoices by email. An invoice, for those who do not know, is basically a receipt that documents how much you were charged, what you were charged for, and what payment method was used to pay for those charges. And you normally receive these invoices after your primary payment method was charged at the beginning of the month. Now, below that is whether or not you want to receive free tier usage alerts by email. Basically, I try to enable this because it's good to know when any of your AWS service usage is approaching or has exceeded the free tier limit. And the last option is for enabling custom billing alerts. So not only based on the free tier limits, but also if you want to be reminded via email when your AWS service usage hits a certain cost or metric amount defined by you. Note that once you enable this option to actually create the custom alerts, you have to either do it through Cloudwatch or through the AWS budgets feature. There will be links in the description below to documentation that has more information on both of those. Next up, on the left side under where it says billing, if you clicked on where it says orders and invoices, that will take you to a page that contains your upcoming payments that are due, as well as your invoices for previously made payments. And above that, if you click on where it says bills, that will take you to a page that gives a breakdown by each AWS service and metric for your current charges for the month so far. You can even select the date up here and change it if you want to see the same breakdown for your AWS service costs and usage, but for another month. For instance, I'm going to choose August 2020. And in addition to the total amount of costs incurred for the month by where it says total or estimated total, like I just mentioned, there is a breakdown of your charges by each AWS service used in that month by where it says details. And if you click on any service under where it says AWS service charges, I'm going to click on the GameLift service, for example. The costs are broken down even further by region. Now, although in this tutorial I primarily use the US East North Virginia region, keep in mind that all of your cost data from all regions will be displayed on this page, despite the URL having a region parameter. And if you click on any region within any service, the costs are broken down even further by metric. I'm going to click on the only region here in my case, which is the US East North Virginia region. Now, in this example, in August 2020 in the US East North Virginia region, I use C5.large Linux GameLift EC2 on-demand instances, C5.large Windows GameLift EC2 on-demand instances, and C5.large Windows GameLift EC2 Spot instances. For the on-demand instance usage, I was not charged for either the Windows or Linux on-demand instance usage because the number of hours between them combined did not go over the free tier limit of 125 hours. Now, since GameLift Spot instances are not covered under the free tier, I was charged for 2 hours of usage, which equated to 30 cents in this case. Now, this number can vary based on a lot of factors such as the region and time period of the instance usage, but we will get to that more later in this video. Moving on to the other tools of this dashboard, on the left side of the screen under where it says cost management, if you click on where it says budgets, that will take you to a page that we talked about earlier where you can literally create budgets to help you track your AWS service costs and usage relative to a budget restriction or threshold. Right above that, if you click on where it says Cost Explorer and then click on where it says Launch Cost Explorer, you will be taken to a user interface that lets you visualize and better understand your AWS costs and usage. In my personal opinion, this may be the most useful feature within the AWS Billing and Cost Management Console. So by default, you should see a page with some boxes. You have up here from left to right your current monthly costs, your forecasted monthly costs, your usage trends for the month, and then a bar graph containing your combined costs across all AWS services used for each day during a specific time period. And finally, your recently accessed reports. The main part of the Cost Explorer is this graph in the middle of the screen, because you can customize this bar graph to outline specific costs and usage data based on different factors. To better explain, go ahead and click on where it says Explore Costs. And that will take you to an expanded and more detailed view of the same graph. Now, below the bar graph, you have a table showing that exact same data in the graph. Also, you can now customize this graph to show cost data based on specific filters. So starting with above the graph where there's a specific time range, you can change this time range. So I'm going to click on it and make this a very long date range so that I have more data to show. So I'm going to choose June 1st as my start date and today, which is September 10th at the time of filming this video, as my end date. Once you have your date range selected, go ahead and click the apply button to apply this time period to this bar graph. You can also click on where it says daily to the right of the time period to change the frequency of the data to be hourly, daily, or monthly. I'm just going to keep it set to its default value of daily. And right below, there is a row of specific things that you can group data by within the bar graph and table below. By default, the data is grouped by nothing. So an easy one to show is service. So if I click on service, you will see in the bar graph that there are now different colored bars denoting how much of the cost per day were allocated to specific AWS services. And in the table below, similarly to the bar graph, the cost data for each day is organized by the costs accrued by each AWS service. Now going back up, I'm going to remove this group by filter by clicking the X button by where it says service, so that I can show the difference between grouping by and filtering your data. So on the right side here, you have a bunch of filters for your cost data. So let's say you only want to see the cost from the Cloudwatch service. You would click on where it says service, and out of this list of services, select Cloudwatch, and then click on apply filters. And after that, you will notice that a lot of this data is now filtered out, because if you notice from before, my total costs since June 1st came from both GameLift and Cloudwatch, but mostly GameLift. So the Cloudwatch costs, as you can see, are very small in comparison. And of course, the filter gets applied to the table as well. So now there's only one row below the header that pretty much denotes the total costs accrued from the Cloudwatch service. The last thing that I want to play around with in the Cost Explorer is that you can actually, in addition to cost data, you can also see specific usage metrics as well. So for example, if I clear the Cloudwatch filter by clicking the X button by it, and then click on service again and select the GameLift service instead, and then click on apply filters. Then down below by where it says usage type, let's say I wanted to check how many hours of C5.large spot instances I used for GameLift, as well as the costs associated for that instance usage time. I will click on where it says usage type, And out of this list, I would go ahead and find where it says spot usage C5.large and then in parentheses hours, and then go ahead and select that and click on apply filters. Since I only have been using C5.large instances for GameLift, and you will now see to the left there are two graphs. One is the cost graph that we've been seeing before, and then there is a usage graph below it that aligns with the cost graph in the sense that for each day you can see how much the amount of spot C5.large instance usage costed, and below these graphs you have the exact same thing but in table form. So not including the header, the first row is the total cost and the second row is the total usage in hours. And that's all I wanted to cover with regards to the AWS Billing and Cost Management Dashboard. I thought that it was important before going over the costs of specific AWS services that I teach you guys watching how to first understand the details of your current and previous billing statements from AWS. For more information on the Cost Explorer and other features of the Billing and Cost Management Console, there will be links in the description below to documentation on both. Moving on, let's take a look at the public documentation out there on pricing for specific AWS services, starting with the big one, Amazon GameLift. Link to this page will be in the description below, and on this page the costs of GameLift are essentially broken down into three major categories. The first one is how much EC2 instances managed by GameLift cost. The second one is how much EC2 instances not managed by GameLift directly, but rather managed by your own custom server layer using Fleet IQ. Now technically it is slightly cheaper to manage your own EC2 instances in AWS by creating your own server management layer using Fleet IQ, but this feature literally just came out, so I did not have enough time to cover this in the tutorial series. Therefore, if you are following this tutorial series, it is very unlikely that you will see a Fleet IQ charge on your invoices. And the last and third one is how much it costs to transfer data from your game servers to your game clients. So let's start with how much it costs to run instances on GameLift. So on this page content on the left side of the screen, I'm going to go ahead and click on Amazon GameLift instances. So if you scroll down a little bit, there will be four tables. The first one contains the pricing data for Linux Spot instances. The next table contains the pricing data for Linux on-demand instances. The table below that contains the pricing data for Windows Spot instances. And the last one contains the pricing data for Windows on-demand instances. So I'm going to go back up to the first table by clicking where it says Linux under where it says Amazon GameLift instances on the left side of the page, and just go over that table because the tables below have the exact same format. Also, Linux Spot instances, when not taking into account the free tier, are the cheapest out of the four fleet types by far, so you should try to use the Linux Spot fleets as much as you can. So with each table, you can select the region that you are operating in, since the prices of EC2 instances does depend on their location as much as they depend on whether the instance is a Linux or Windows one, and whether the instance is part of an on-demand or spot fleet. So since I have been primarily doing the tutorial series in the US East North Virginia region, I'm going to select that one, but feel free to select the one that you have been using. In addition to that, if we look at the header of this table, you will notice that the first column is titled Instance Type. So remember when you made a fleet in GameLift, you had a bunch of instance types you could choose from. The one we are most familiar with is C5.large, because it is one of the cheapest instance types as well as one of the free tier eligible instance types on this list of instance types. Note that the difference between each instance type besides cost is the actual specifications of the hardware between these virtual computers. For instance, some instance types have more CPU cores than others, and some instance types have more RAM than others. We will have a link in the description below to documentation that specifies the exact hardware of every single EC2 instance type available in AWS. The next column in this table is titled Hourly Spot. So for on-demand instances, this column will be titled Hourly On-Demand, but they both mean the hourly price for one running active instance, regardless of whether or not it is hosting active game sessions or even running server processes. As long as the instance is considered quote-unquote on, then you will be charged for the amount of time each instance is active separately. For example, taking the top row in this table, if you had two M5.large Linux Spot instances in the US East North Virginia region, in this case, that were active for 50 hours each this month. That would be 100 hours total of M5.large Linux spot instance usage time in the US East North Virginia region, which would cost approximately this price on my screen right now, 0.04476 times 100, which is about $4.48, and that will be the charge on your invoice for this month. The last column represents an estimate of how much it would cost to run one active instance for 365 hours per month using auto-scaling. And as you can see, the hourly prices as well as the monthly 365-hour cost estimate with auto-scaling are different for each instance type. Typically, better hardware leads to more expenses per hour to run an instance managed by GameLift. Now keep in mind that the pricing data for spot instances, whether they are Linux or Windows, can get tricky because the hourly price can change. So if we scroll up to where it says 3 months of historical pricing and savings data, go ahead and click on that and you should see a line graph of the on-demand price of a Linux or Windows instance type versus the spot price of that same instance type. In my case, the graph defaulted to showing the hourly on-demand and spot prices of a Linux C5.large instance in the US West Oregon region. You can configure all of these values to see the difference between the hourly on-demand and spot prices for any Linux or Windows instance type in any region, but I'm only going to change the time period of this graph from its default value of 1 month to the maximum possible value, which is 3 months, to better show that the hourly price of a spot fleet can fluctuate from time to time, whereas the on-demand price is fairly constant and not subject to change as often in comparison. So what does this mean? You may be wondering, what if I'm running a spot instance while the price changes? When you launch a spot instance, again, whether it's Linux or Windows, the hourly price of that instance for the next hour is whatever the hourly price is for that instance type in the region currently. Therefore, even if the price changes within that hour, it doesn't matter because the price is set in stone every hour. So after each hour while the instance is active, the price for the subsequent hour is whatever the current spot price is for that instance type in that region. Now, I do have to point out some differences in pricing between Linux and Windows instances. You have just seen the major cost difference between spot instances and on-demand instances, with spot instances being significantly cheaper. And the other difference between spot and on-demand is that spot prices can change while on-demand prices are stable. Now, there is a similar difference between Linux and Windows instances in that Linux instances are significantly cheaper than Windows instances. For example, remember the hourly spot and on-demand prices for a C5.large Linux instance in the US West Oregon region. And then let's change the product in this graph from Linux to Windows. And you will notice that the hourly price of a C5.large Windows spot instance is indeed more expensive than that of the C5.large Linux spot instance. Also, the hourly price of a C5.large Windows on-demand instance is greater than that of the C5.large Linux on-demand instance. And another major difference between Windows and Linux instances involves how their usage time is tracked for billing purposes. In both cases, the time that is tracked is the amount of time that instances are active, starting from when they start up until when they shut down. But with Windows instances, the usage time is tracked by the hour, meaning that partial hours count as full hours. For instance, if a particular Windows instance is active for 1 minute, or that same Windows instance is active for 59 minutes, both scenarios are treated as 1 hour of Windows instance usage time in the eyes of AWS billing. Essentially, the amount of time a Windows instance is in use gets rounded up to the nearest whole hour for billing purposes. Another example would be if you had 2 Windows instances of the same type in the same region. One was active for 2.5 hours while the other one was active for 1.5 hours. You would be charged for a combined total of 5 hours for that Windows instance usage time. On the other hand, with Linux instances, the usage time is tracked by the second, meaning that Linux instance usage time is charged by the second with a 1 minute minimum charge. So let's say for whatever reason an instance started up and was only active for 30 seconds before terminating. You would be billed for 1 minute of Linux instance usage time. And if this happened on, let's say, 10 separate occasions in a month, then you would see on your invoice for that month a charge for 10 minutes of Linux instance usage in GameLift. But after the first minute of a Linux instance being active, you are then billed by the second thereafter until the instance shuts down. For example, if you have a Linux instance that ran for 8 minutes and 43 seconds, then that would be treated as exactly 8 minutes and 43 seconds of Linux instance usage time, and you will only be charged for that amount of time based on the hourly price. So let's say that the instance was of type C5.large. It was a spot instance in the US West Oregon region, and it was active sometime today in the last 3 hours. So taking the latest spot price, which is about 4 cents, and multiplying that by about 0.145, since 8 minutes and 43 seconds is about 14.5% of an hour, that is approximately $0.0058, which is what you would be charged for that amount of Linux spot instance usage time. Now let's go back to the GameLift pricing page so that we can move on to the next section, which is the GameLift Fleet IQ section. Like I said earlier, it is slightly cheaper to manage EC2 instances with your own custom server management layer and the GameLift Fleet IQ service than having Amazon GameLift manage those same EC2 instances for you directly. I will have more information about Fleet IQ in general in a documentation article linked in the description below. But the pricing data for this section is similar to that for the Amazon GameLift instances section in the sense that it consists of 4 tables, one containing the pricing data for Linux spot instances, one containing the pricing data for Linux on-demand instances, one containing the pricing data for Windows spot instances, and one containing the pricing data for Windows on-demand instances. And the last component of costs when it comes to Amazon GameLift is data transfer out from Amazon GameLift instances to the internet. When you have EC2 instances running on GameLift hosting multiple processes of your game server executable, and you have clients connected to these game server processes, as games go on, information will be transferred between the clients and the server. That is how clients get updated information about other clients connected to the same server that they are all connected to. This is the heart of multiplayer gaming. A common example that we have seen throughout this tutorial is movement replication. When one client moves, how do the other clients connected to the same server see that client's moving animation as well as the client's position changing frame by frame? The answer is that the client that is moving sends information about its movement state, position, and more to the server, and that information gets replicated to all of the clients so that all the clients can see on their screen that this one client is actually moving. You don't notice it, but behind the scenes, many small packets of information are sent from the client to the server. For each packet, the server processes this information, then the server sends a small packet of information back to the client so that they can process that information to simulate what's going on the server. The rate at which these packets of information are sent and processed is very fast. That's why movement replication and other forms of replication look so smooth that you don't even realize that so much is going on to make it look so smooth. Essentially, clients are mirrors and reflections of the server they are connected to. That is why internet connection and speed is so valuable in multiplayer games, because data is consistently transferred between the server and client at such a fast rate. Fortunately for us, you are only charged for the amount of data sent by the server to the clients when it comes to EC2 instances hosted on and managed directly by GameLift. You will not be charged for inbound data transfer, aka the amount of data sent from the client to the server. And in this section, you have a table that lists out the cost of data transferred out per gigabyte for certain thresholds. For example, luckily with the free tier, the first gigabyte of data transferred out per month is free. After the first gigabyte in a month, the next 9.999 terabytes of data transferred out that same month are charged a certain amount for each gigabyte transferred. For example, in the US East North Virginia region, it's 9 cents per gigabyte. Then after the first 10 terabytes in a month, the next 40 terabytes of data transferred out that same month are charged a certain amount for each gigabyte transferred. For example, in the US East North Virginia region, it's 8.5 cents per gigabyte. Then after the first 50 terabytes in a month, the next 100 terabytes of data transferred out that same month are charged a certain amount for each gigabyte transferred. For example, in the North Virginia region, it's 7 cents per gigabyte. And after the first 150 terabytes in a month, any more data transferred out that same month is charged, in this case in the North Virginia region, 5 cents per gigabyte. And although this is highly unlikely for most of you guys watching, let's say in 1 month, a total of 60 terabytes of data are transferred out from server processes on instances in your fleets in the US East North Virginia region to clients. The first gigabyte would be free. Then the next 9.999 terabytes would be charged 9 cents per gigabyte, which would equate to $889.91. Then the next 40 terabytes would be charged 8.5 cents per gigabyte, which would equate to $3,400. Then the last 10 terabytes would be charged 7 cents per gigabyte, which would equate to $700. That means on the invoice for that month, you would receive a data transfer out charge for GameLift for a sum of approximately $4,989.91. Keep in mind that this pricing data can vary with each region, which you can adjust up here. Also, this cost metric is why it is so important to optimize your game when it comes to replication and data transfer, whether it's information about the level, models, graphics, players, non-player actors, animations, effects, etc. All of it matters, especially for bigger games with bigger levels and lots of players. The problem of multiplayer data optimization magnifies as more and more data is being transferred between the server and clients. Fortunately, Unreal Engine's replication system is pretty optimized and will suit most developers' needs, so you won't have to worry too much about data transfer optimization or minimization when developing multiplayer games. Next on this page that I highly encourage you guys to read over on your own time is a pricing example where they go over a mock example with graphs and models of how much a game hosted in a specific region costs over a specific period of time when it has X amount of players, Y amount of instances, and Z amount of data transferred out, while comparing the cost with and without auto-scaling and with spot versus on-demand instances. And the last thing on this page is information about the free tier for GameLift. AWS offers a bunch of free offers for its services, not just GameLift, so that people can try out AWS services for up to specific amounts without charge. In the case of GameLift, for example, upon signing up for a new AWS account for the first year, you will receive up to 125 hours of Amazon GameLift C5.large on-demand instance usage and 15 gigabytes of bandwidth out from instances hosted on GameLift per month, both for free. Of course, you can use more than 125 hours of GameLift C5.large on-demand instances and 15 gigabytes of bandwidth out per month, but then you'll start being charged for any usage beyond the free tier limit. And that is pretty much it with regards to pricing information about GameLift. Like I just mentioned, the AWS free tier does not only apply to just GameLift, but also applies to other AWS services. You can actually explore all the free offers that AWS provides by going to this AWS free tier page. Link will be in the description below. Note that unlike GameLift, there are also free tier offers that do not expire after the first 12 months upon opening an AWS account. And there are also free tier offers that last for a limited amount of time for services once those specific services are activated for the first time on an AWS account. The free tier offers for GameLift that we just went over fall under this 12 months free category, meaning that they are only applied to AWS accounts younger than a year old. All the free tier offers can be checked out below in this user interface under where it says free tier details, and they can also be filtered through the different toggles on the left side of the page. Moving on to the other AWS services that we use for this tutorial series, let's go to the pricing details page for Amazon API Gateway. Link to this will be in the description below. In case you have forgotten, we made a REST API on API Gateway in this tutorial so that our Unreal Engine game clients would be able to communicate with an AWS Lambda client service through HTTP requests made to our REST API. So if we scroll down a little bit, the very first thing talked about is the free tier. So for the first 12 months since the opening of your AWS account, you are given 1 million free API calls received for REST APIs, 1 million free API calls received for HTTP APIs, and 1 million free messages and 750,000 free connection minutes for WebSocket APIs per month. Now moving on to the next section, they have the pricing details for HTTP APIs. Although we did not use HTTP APIs since it is a fairly new feature in API Gateway, I would highly encourage you guys to explore HTTP APIs on your own time because they are similar in functionality to REST APIs and slightly cheaper than REST APIs. For example, in this table down below, you can see the price per million requests for the first 300 million requests received by HTTP APIs in a month, and the price per million requests for the requests received after the first 300 million received that same month. Then go down to the same table for REST APIs, which is what we used in this tutorial, and you will notice that the prices per million requests for the first 333 million requests received by REST APIs, the next 667 million requests received after that, the next 19 billion requests received after that, and any more requests received after that in a month are all greater than any of the prices per million requests received by HTTP APIs. And of course, note that these prices do depend on the region where the API is hosted, which you can configure for both tables. Also, if we scroll down a little bit, you will see the pricing details for API caching for REST APIs. Note that we did not use caching in this tutorial, but for REST APIs, you can use caching to reduce the number of calls made to your API endpoints and improve the latency of requests made to your APIs. Essentially, responses can be cached for a specified period of time. Then, as requests are made, API Gateway first looks for a response from the cache before making a request to the requested endpoint. Therefore, for APIs that receive similar looking requests very often or frequently, caching can potentially increase the speed at which applications get responses from requests made to REST APIs. Note that this doesn't save money because an API response served via cache data is still considered an API received request for billing purposes. On top of that, when you enable API caching, you are then charged for the amount of memory used to temporarily hold cached responses, and the pricing for the amount of cache memory used per hour can be found in this table below. Going further down this page, again, although we did not cover WebSocket APIs, I would highly encourage you guys to explore that since WebSockets should have been used for sending matchmaking request updates to clients instead of having to do simple polling through periodic HTTP requests to query a Dynamodb table. In addition to that, WebSockets are critical in other features of multiplayer games such as a chat system, a friend system, a lobby/party system, and more. But here in this table, you have the cost per million requests as well as the cost per million connection minutes, which are both dependent on where the API is hosted. And before we move on, I do want to mention that there can be requests sent to APIs, whether they are sent to an HTTP, REST, or WebSocket API that do not count for billing purposes. Link to this page will be in the description below, but essentially all API requests that fail authorization or authentication checks do not get counted for billing. For example, in our REST API, we have some methods that are authorized by a Cognito user pool. So in cases where the incoming requests to those specific API endpoints do not contain a valid access token, then you will not be charged for that specific request. Going back to the API Gateway pricing page, in the next section there are links to various services that API Gateway may invoke that can incur additional charges. So out of these 4 services listed, we are only concerned about data transfer, AWS Lambda, and Amazon Cloudwatch, because AWS Private Link is only applicable if you made a private API or are using virtual private cloud endpoints. neither of which we did in this tutorial. Going back to the other 3 services that may be automatically used by API Gateway, starting with Cloudwatch. API Gateway automatically by default sends metric data for your APIs to Cloudwatch every minute. Metric data includes the number of 400 code errors, the number of 500 code errors, the number of requests made, the latency, and more. Just to show you guys, let me go to the Cloudwatch homepage, and on the left side select where it says metrics. Then select API Gateway, then select by API name, and since we only deployed one API for this tutorial, for each row in this table down here, the API name is the same, but if we click on a checkbox to enable one of these metrics down here to show up in the graph above and change the time period up here to be a longer period of time, for example 4 weeks, we can start seeing data for that enabled metric for that specific API over a given period of time. In this case, the graph up here shows the number of API requests received at different times within the last 4 weeks. Now, someone please correct me if I'm wrong, but I believe that you don't get charged for this. You don't get charged for API Gateway sending the default metric data to Cloudwatch, and I will have a link in the description below to a piece of documentation that has a list of all the default metrics that API Gateway sends data to Cloudwatch for every minute. As a result, everything else related to Cloudwatch that API Gateway is involved in that can cost you money technically has to be enabled by you. For example, if you want to create multiple dashboards with the API Gateway metric data supplied to you, if you want to create your own custom metrics for API Gateway, if you want to enable execution or access logging in Cloudwatch for your APIs in order to help debug issues, or if you create multiple alarms in order to help you monitor API Gateway. We didn't do any of that in this tutorial, but you can be charged for all of those activities just mentioned when you perform them in amounts beyond the free tier. We will go over Cloudwatch costs more in depth later in this video. Next, going back to the API Gateway pricing details page, specifically moving on with the rest of the services that are commonly used in combination with API Gateway that are applicable in this tutorial and can incur additional charges. With AWS Lambda, obviously our REST API methods invoke Lambda functions, so you will be charged for those Lambda function invocations. Like Cloudwatch, we will dive deeper into Lambda pricing later in this video. As for the data transfer costs, when responses are sent back to applications that originally made requests to an HTTP or REST API, that data transferred out from API Gateway to whatever application is tracked for billing purposes. So you get charged for the amount of data transferred out from an HTTP or REST API unless it's a private API, but in that case you have to then pay for AWS private link. Going back to the data transfer out costs, similar to GameLift, to figure out the exact cost, go to this EC2 on-demand pricing page, link in the description below, click on where it says data transfer on the left side of the screen, select the region where your API is located, in my case it's US East North Virginia, and focus on where it says data transfer out from Amazon EC2 to internet. The table right under it says what it will cost per gigabyte of data transferred out for different thresholds, exactly like how it is for GameLift's and most AWS services data transfer out costs. Going back to the API Gateway pricing details page, just to clarify, for WebSocket APIs, the costs work differently than they do for HTTP and REST APIs. You are not charged for data transfer or API calls received. Rather, you are only charged based on the number of messages sent and received, as well as the amount of connection minutes. And the last things on this page include some pricing examples for each type of API and a couple of links to more resources on pricing, both of which I highly encourage you guys watching to take a look at on your own time. Now moving on to the AWS Lambda pricing details, link to this page will be in the description below. Lambda is the backbone of the client service that the client invokes by making HTTP requests to REST API methods on API Gateway. This Lambda-based client service is how Unreal Engine clients indirectly communicate with other AWS services such as GameLift, Dynamodb, and others in order to get into a game server hosted on an EC2 instance on GameLift. We also used AWS Lambda in the Cognito user pool that we made in this tutorial specifically for the callback URL for an app client for that user pool. I forgot to mention this earlier when talking about API Gateway, but that callback URL technically involves API Gateway too, since a Lambda function requires an API on API Gateway for the function to be invoked by a resource URL. In addition to that, we use Lambda functions for a pre-setup trigger and a post-confirmation trigger in order to prevent multiple accounts with the same email from existing in our user pool, and to initialize a new item in the player data Dynamodb table whenever a new account was successfully made, respectively. Consequently, there are a lot of hidden costs with regards to Lambda and API Gateway involved in Cognito that we will go over later in this video. We even wrote an AWS Lambda function for updating player and match statistics on DynamoDB that the server called through a REST API method. Looking back, this method should have been part of a private API, but we did write another Lambda function for a custom Lambda authorizer that provided a weak password check on the API method for updating stats. The point of me saying all of this is to point out that AWS Lambda is very heavily used in this project. So let's move on to the pricing details. With AWS Lambda, you are mainly charged on two things: the number of requests made to your functions and the total duration of the function calls. A request counts towards billing each time the Lambda function starts executing. Once that handler function in Node.js or any language offered by AWS is invoked and it starts stepping through the body of the function, whether or not the function call ends successfully, that counts as a request in a region in the eyes of AWS billing. As for duration, the total time it takes from when the handler function starts to when it returns or terminates every time a Lambda function is called, whether or not the function call ends successfully, contributes to the total duration for all of your Lambda function calls combined in a region for billing purposes. Luckily, the free tier for AWS Lambda comes with 1 million free requests and 400,000 gigabyte seconds of free compute time per month, and this offer does not expire after the first 12 months of opening your AWS account, so this offer is always available to all AWS users. And in this table down here below where it says AWS Lambda pricing, depending on which region the AWS Lambda function is hosted on, you have the price per million requests, which tends to be constant. Unlike API Gateway, the price does not change after you cross certain benchmarks for the number of Lambda requests made in a month. As for duration, it does give you the price for every gigabyte second spent while executing Lambda code. And the reason why the metric is measured in gigabyte seconds is that every Lambda function is allocated a certain amount of memory or RAM. By default, the lowest amount of memory possible, 128 megabytes of memory, is allocated to a newly created Lambda function. And in this tutorial, we did not change the amount of memory allocated to any of our Lambda functions. So by default, each Lambda function in this tutorial only has 128 megabytes of memory allocated to it. Therefore, you would have to multiply this price metric for the duration in the small table by 128 divided by 1024 in order to get the price for every 128 megabytes per second for calculating Lambda cost for this tutorial project, which is about $0.000002083 per second for Lambda functions allocated 128 megabytes of memory. However, you can change the amount of memory allocated for each Lambda function to be a different amount. Technically, more memory will lead to better performance, so it could lower the duration of your Lambda function calls, but that doesn't necessarily lower your duration costs because, as we just talked about, Lambda duration costs are calculated both on time and memory. This table down here gives you some examples of different prices per 100 milliseconds, which is 0.1 seconds for the duration of calls to Lambda functions allocated different amounts of memory in megabytes. Note that in this case, 1024 megabytes is equivalent to 1 gigabyte. Scrolling further down this AWS Lambda pricing section, you have some examples which I encourage you guys to look over on your own time, and we're going to skip the provision concurrency pricing section since we did not do provision concurrency in this tutorial. Moving on to the data transfer and other charges section. Luckily, data transferred in and out of AWS Lambda functions inside the region that they are hosted in will not be charged, with some exceptions. So in our case, because our REST API and Cognito user pool that both invoke Lambda functions are located in the same region as all of our Lambda functions, we don't get charged for data transfer when it comes to Lambda in this tutorial project. However, if the data is transferred between Lambda and other AWS services or applications in other regions than the one that the Lambda function is hosted on, then you will be charged for data transfer, and those prices are exactly the same as those for GameLift and API Gateway that we looked at earlier on this EC2 on-demand pricing page in the data transfer section. But now you have to consider data transfer in to Amazon EC2 from internet, data transfer out from Amazon EC2 to a specific region, and data transfer within the same AWS region. Going back to the Lambda pricing details page, just want to make a quick note on other charges that can be incurred by our Lambda functions invoking other AWS services. So in our case, we have a Lambda function that calls another Lambda function, so that scenario still falls under the category of general AWS Lambda pricing. But we also have a lot of Lambda functions that read and write to tables in DynamoDB, which we will explore the cost of later in this video. Next on this page is a calculator, which I highly encourage you guys to explore on your own time, and we are going to skip the Lambda at Edge pricing section because we did not use Lambda Edge in this tutorial. Like I mentioned earlier, we do have Lambda functions in this tutorial project that read and write to tables in DynamoDB, and those kinds of operations do cost money. So let's go to the pricing details page for DynamoDB. Link to this will be in the description below, and what you will notice is that the pricing page is divided into two more pages, one for on-demand capacity mode pricing and another for provision capacity mode pricing. And the main difference between on-demand and provision capacity is that with provision capacity, you specify ahead of time the number of reads and writes per second that you expect to happen with your tables. Resources are allocated to those tables to always be able to handle that provision capacity. Then with auto-scaling, DynamoDB will adjust resources when the actual number of reads and writes occurring per second becomes greater than the provision amount for your tables, in order to try to handle that increase in throughput, in order to save resources and reduce costs while making an effort to maintain good performance on those read and write operations. On the other hand, with on-demand capacity, you don't specify how much read and write throughput that you expect your tables in DynamoDB to encounter ahead of time, because in on-demand mode, the resources allocated to your tables theoretically can handle any workload traffic with good performance, being able to adjust for even very rapidly changing numbers of read and write operations per second. Although in provision mode, auto-scaling is used to adjust to changing workloads, the adjustments made by auto-scaling may not handle very fast-paced changes in traffic as well as those made in on-demand mode performance-wise. Keep in mind though that read and write operations in on-demand mode are significantly more expensive than those in provision mode. Everything else related to DynamoDB costs is the same between the two modes, minus global tables, but we don't need to worry about that since we don't use global tables in this tutorial. However, because you don't specify an exact number of read and writes per second with on-demand capacity, you do truly pay for what you use, since it is a constant price for each read and write, depending on the amount of data read and written, as can be seen in this table down here in the pricing for on-demand capacity page, under where it says read and write requests. You may have to expand this section in order to see it. And you can see that in the US East North Virginia region, or whatever region is selected here by default, you are charged $1.25 per million write request units and 25 cents per million read request units. Keep in mind that one write or read operation does not equate to one write request unit or one read request unit, respectively. In on-demand mode, each write and read operation is charged based on the amount of data the operation writes to a table or reads from a table. For non-transactional write operations, which applies to us because we don't do transactional writes at all in this tutorial, you are charged one write request unit for every kilobyte of data written. So in our case, it's very rare that a write operation will be charged for more than one write request unit. For read operations, the amount of read request units you are charged for depends on the consistency of the read operation. Since we did not specify otherwise in this tutorial, all of the read operations performed by default are known as eventually consistent reads. We don't use transactional nor strongly consistent reads. Strongly consistent reads are guaranteed to give you the most up-to-date data, while eventually consistent reads can give you older data, not reflective of the results of a recently completed write operation. More information about that will be in some documentation linked in the description below. However, strongly consistent reads cost more read request units, hence more money. But for eventually consistent reads, you are charged only half of a read request unit for every 4 kilobytes of data read from the table. In our case, it's very rare that a read operation will be charged for more than half of one read request unit. So for example, in 1 month, if you perform 1 million write operations, each writing less than 1 kilobyte of data, which could result in writing up to 1 million kilobytes, aka 1 gigabyte worth of data, to tables in on-demand mode, you would be charged $1.25 that month for 1 million write request units. And in that same month, if you performed 2 million eventually consistent read operations, each reading less than 4 kilobytes of data, which could result in reading up to 8 million kilobytes, aka 8 gigabytes worth of data from tables in on-demand mode, you would be charged 25 cents for 1 million read request units. Whereas with provision capacity, you are charged per hour based on the current total throughput capacity across all tables in provision mode combined, which is also based on the amount of data written and read per second, even if applications interacting with those tables don't perform enough reads and writes that utilize the full capacity, whatever it is at the time. So you may end up getting charged for unused resources. But the reason why we use provision mode in this tutorial for all of our DynamoDB tables is that the free tier for on-demand capacity does not offer any free read and write operations, not even one, whereas the free tier for provision capacity offers 25 write capacity and 25 read capacity units of provision capacity per month per region for free. And the likelihood of any of us needing over 25 write capacity units and 25 read capacity units of provision capacity at any time is very, very unlikely. The conversion between write capacity units and read capacity units to write operations and read operations in terms of the amount of data written and read from those operations is similar to the conversion that we just talked about with write request and read request units in on-demand mode. One write capacity unit is counted for each kilobyte of data written by a write operation to a table, and half of one read capacity unit is counted for every 4 kilobytes of data read by an eventually consistent read operation from a table. Now, assuming that each write operation performed does not write over 1 kilobyte of data, and each eventually consistent read operation performed does not read over 4 kilobytes of data, both of which are very likely in our situation, 25 write capacity units and 25 read capacity units per second, the threshold limit of the provision throughput covered by the free tier that you do not have to pay for all tables combined, is equivalent to 25 write operations writing up to 25 kilobytes of data to tables in provision mode per second, and 50 eventually consistent read operations reading up to 200 kilobytes of data from tables in provision mode per second. So unless the total provision throughput capacity of all your tables combined scales beyond 25 kilobytes written per second or 200 kilobytes read per second, you will not be charged. Really quickly, I just want to go to the Dynamodb Dashboard to better visualize what we mean when we talk about provision capacity. So straight off the bat, it tells you in the left side middle of the screen how many read capacity units and write capacity units you have provisioned across all tables in the region currently. In this tutorial, we made 3 tables in this region, each with a default minimum provision capacity of 5 read capacity units and 5 write capacity units, totaling 15 read capacity units and 15 write capacity units across all 3 tables, and a default maximum provision capacity of 40,000 read capacity units and 40,000 write capacity units, totaling an amount greater than 80,000, but by default each AWS account has a maximum of 80,000 read capacity units and 80,000 write capacity units that can be provisioned for all the tables combined in a region, unless you request a service quota increase from AWS, which we touched upon in the last part of the tutorial. Now let's take a look at an individual table by clicking on where it says tables on the left side, and then select any of the tables out of the 3 we made. I'm just going to choose the matchmaking tickets table, even though they are all the same for what I'm about to show. Then go to the capacity tab, and in here you will see information relevant to the provision capacity for this table. And under where it says auto scaling, you will see that the target utilization for both reading and writing is 70%, meaning once the amount of actual read and write capacity units processed per second remains greater than 70% of the current provision capacity for about 2 to 5 consecutive minutes, auto scaling will be triggered and the provision capacity will increase until the current workload is less than or equal to 70% of the new provision capacity, or until the provision capacity reaches its maximum possible value, which is either 40,000 capacity units or enough capacity units to make the total provision capacity across all tables sum up to 80,000 capacity units. And when the amount of actual read and write capacity units processed per second is way lower than the current provision capacity, at least less than 20% below the target utilization. So in our case, when the amount of actual read and write capacity units processed per second is less than 50% of the current provision capacity for about 10 to 15 consecutive minutes, auto scaling will be triggered, but this time the provision capacity will decrease while the current traffic remains less than or equal to 70% of the new provision capacity, or until the provision capacity reaches its minimum possible value. As we have learned from the last part of the tutorial, scaling up is almost always faster than scaling down. So one example in which you can get charged for this tutorial project with regards to DynamoDB is, let's say the number of data getting read from and written to one of the tables, let's say this one, the matchmaking tickets table, gradually ramps up to about 70% of 20 write capacity units and 20 read capacity units per second. So no more than 14 write operations totaling no more than 14 kilobytes of data being written to this table per second, and no more than 28 eventually consistent read operations totaling no more than 112 kilobytes of data being read from this table per second. And this occurs for some time so that the table's provision capacity can gradually auto scale up to 20 write capacity units per second and 20 read capacity units per second. And let's say the provision capacity for this table stays at 20 capacity units per second for reading and writing for about an hour, until it scales back down gradually to its minimum provision capacity of 5 capacity units per second for reading and writing. During that entire hour, let's assume that the provision capacity for each of the other two tables did not increase beyond the minimum provision capacity of 5 capacity units for both reading and writing. Then in that case, for that 1 hour when the provision capacity of the matchmaking tickets table was at 20 capacity units for both reading and writing, the total provision capacity across all three tables, 5 plus 5 plus 20 for each reading and writing, was a total of 30 capacity units. Because 30 is above the free tier limit of 25 capacity units for both reading and writing, you will be charged in this example for the 5 capacity units over the free tier threshold for both reading and writing for that 1 hour. The other 25 capacity units still fall under the free tier, but the extra provision capacity would have costed 5 writing capacity units times $0.00065 and 5 reading capacity units times $0.00013, given that the tables are all in the US East North Virginia region, which is a grand total of $0.0039. Keep in mind though that this kind of scenario is very, very unlikely unless you have a very popular game. And I also want to quickly go to the billing and cost management dashboard, specifically the bills page, because I want to clarify some confusion about what you see under the DynamoDB section with regards to the details about provision capacity hours used each month. I'm going to look at a month that's already been completed, so I'm going to choose August. Now throughout this whole month, every single day, every single hour, each table I have in DynamoDB was active, but its provision capacity never auto-scaled beyond the minimum of 5 read capacity units and 5 write capacity units. As a result, the number of capacity hours used for the month was 31 days times 24 hours times 15 total capacity units spread across 3 tables for each reading and writing, which equals 11,160 read capacity unit hours and 11,160 write capacity unit hours. Because the total provision capacity across all 3 tables never scale beyond the free tier limit of 25 capacity units for either writing or reading, the cost of all of these capacity unit hours is 0. Finally, to end the comparison discussion about provision versus on-demand, provision capacity is meant for tables that have predictable application traffic that is consistent or ramps gradually. and I would only recommend using on-demand capacity if your tables are receiving a huge amount of traffic that can be unpredictable and at times go up or down very rapidly, because that is what on-demand is truly meant for. Provision mode is meant for saving money when the workload is light and predictable. Moving on with the pricing details for provision mode, since like I said earlier, all the other costs associated with DynamoDB, minus the exception of global tables, are the same between provision and on-demand. But now I'm just going to focus on the things that are relevant to our project. So down here is the pricing for reserve capacity, which we did not use. Then further down we have the pricing for data storage. So essentially you are charged based on the amount of data stored across all of your DynamoDB tables in a region, regardless of whether or not their capacity is provision or on demand. Luckily with the free tier, you don't have to pay anything for the first 25 gigabytes stored per month, but you have to pay 25 cents for every gigabyte stored thereafter per month. So for example, if we had 30 gigabytes stored across all of our tables in the US East North Virginia region during 1 month, then 25 gigabytes of that data storage would be free, but the other 5 gigabytes of data storage would cost $1.25. And then moving further down, we don't use backup and restore, global tables, DynamoDB accelerator, and although we don't explore DynamoDB streams in this tutorial, I would highly encourage you guys watching to look at this in your own time, because once again, I do recommend using DynamoDB streams with WebSocket APIs when you are getting more serious about making multiplayer games with Unreal Engine and AWS. Next, for data transfer, nothing has changed. It's the same as the cost for data transfer for any other AWS service. Luckily, all of the data transfer done with DynamoDB in this tutorial occurred between DynamoDB and other AWS services within the same region, so we will not get charged for that. Next, we have more information about the free tier. By the way, I forgot to mention that the free tier for DynamoDB is categorized as always free, so these offers will last beyond the first 12 months since your account first opened up. Lastly, there are a couple of pricing examples and additional pricing resources, both of which I encourage you guys to check out on your own time. So moving on to the next AWS service that we use in this tutorial, Amazon Cognito. For this project, we made a Cognito user pool, and the main metric for billing purposes is the amount of monthly active users, or MAUs, that the user pool has per month. A user in your user pool is only considered active for the month if at least one identity operation related to that user was performed that month. Identity operations include signing up, signing in, refreshing a token, and changing a password. Once a user is considered active for a month, you will only be billed at most one MAU or request for that user for that month. If a user is inactive for a month, meaning that an identity operation related to that user was not performed that month, then that user will not count as an MAU towards billing purposes for that month. Fortunately, with the free tier, you are not charged for up to 50,000 monthly active users per month who sign in directly to Cognito user pools, and up to 50 monthly active users per month who are federated through SAML 2.0 based identity providers. And this part of the free tier for Cognito does not expire ever, so it's always offered to AWS accounts every month, regardless of how old the account is. Now, in this tutorial, we have users sign in directly, either through the Cognito identity provider or another social identity provider such as Google, even though Apple, Facebook, and Amazon would also fall under this category too if you implemented social sign-in into your user pool with any of those other providers. We do not have users sign in through SAML or OpenID Connect Federation, so we will ignore that portion of pricing details on this page. In this table, under where it says users who sign in directly with their user pool credentials or with social identity providers, you have a table that gives you the price per monthly active users at different thresholds in a specific region where the user pool is hosted in. For example, if your Cognito user pool is hosted in the US East North Virginia region, then like we already mentioned, the first 50,000 active users in a month are free. Then the next 50,000 active users after the first 50,000 in that same month cost $0.0055 per user. The next 900,000 active users after the first 100,000 in that same month cost $0.0046 per user. The next 9 million active users after the first million in that same month cost $0.00325 per user, and any more active users beyond the first 10 million cost $0.0025 per user. So let's say you have 2 million active users in a month for your user pool in the North Virginia region. You would be charged nothing for the first 50,000 active users, but then you would be charged $0.0055 times 50,000 for the next 50,000 active users. You would be charged $0.0046 times 900,000 for the next 900,000 active users, and you would be charged $0.00325 times 1 million for the rest of the active users, giving you a total cost of $7,665 for that month. Moving on, again, we didn't use SAML or OpenID Connect in this tutorial. Also in this tutorial, we didn't use advanced security features. We didn't use text messages for multi-factor authentication. We never migrated existing user directories to Cognito user pools, and we didn't use Cognito Sync. On to the next AWS service that we use for this project, Amazon SNS, also known as Simple Notification Service. We use SNS primarily for flex match, publishing event notifications from GameLift about our matchmaking requests to our SNS topic, and sending those messages to a Lambda function that is subscribed to that topic. That Lambda function then writes relevant data from those matchmaking event notifications to the matchmaking tickets Dynamodb table so that our Unreal Engine clients can later invoke an API method, thereby invoking a Lambda function that reads from that same table in order to get the latest updates on their matchmaking tickets. So in that example, we mentioned the three biggest and relevant components of pricing when it comes to Amazon SNS, starting with publishes. When an application, in our case, it's usually GameLift or FlexMatch, sends or publishes messages to an SNS topic, you are charged based on the number of requests made to publish a message. A message is billed for one request for every 64 kilobytes of data and its payload. Note that Amazon SNS only allows a maximum size of 256 kilobytes for each published message, and that the price of publishing a message depends on the location of where the SNS topic is hosted in. Luckily, with the free tier, the first 1 million published requests per month are free. However, I'm not sure if this is 1 million per region or 1 million for all regions combined, so you may have to do some further research on that. But for every 1 million SNS published requests thereafter in the US East North Virginia region, you will be charged 50 cents. Now, let's say that an application or any AWS service publishes 3 million messages, each of them containing no more than 64 kilobytes of data to a topic hosted in the US East North Virginia region in 1 month. You would not be billed for the first 1 million requests covered under the free tier, but you would be billed for the next 2 million requests for a total of $1. Note that this free tier offer never expires. Next, with notification deliveries, after a message gets published to an SNS topic by whoever, the message is then delivered to all of the applications and services subscribed to the topic. The types of endpoints that can be subscribed to a topic include mobile push notifications, SMS, email, HTTP, Simple Queue service, and Lambda functions. Luckily, in our case, the only SNS topic subscription we made in this tutorial is a Lambda function, specifically the Track Events Lambda function that is subscribed to the FlexMatch event notifications topic, and there is no SNS charge at all for any message deliveries made to Lambda functions subscribed to SNS topics in any region. You will still get charged by Lambda like you would normally when a Lambda function gets invoked by a notification delivery, but you will not ever be charged by SNS in these scenarios, no matter how many messages are delivered from SNS topics to Lambda functions, and no matter how old your AWS account is. Lastly, with data transfer, the costs are pretty much the same as they are for data transfer for other AWS services. Luckily, with the free tier, you get 15 gigabytes of data transfer out across a variety of AWS services combined each month for free for the first 12 months of your AWS account opening. However, I'm not sure if this applies per region or across all regions combined, so you may have to do some further research on your own to find out. And the other stuff on this page includes the pricing for worldwide SMS, which we did not use in this tutorial, and additional pricing resources, which I encourage you guys to check out. And finally, the last AWS service that was used in this project is Amazon Cloudwatch. By the way, may have forgotten to mention this a few times, but there will be links in the description below to all the pages that we looked at in this video. Now, I wanted to go over Cloudwatch last because it can be involved with any AWS service you use, and although there are a lot of features of Cloudwatch that you can be charged for, the main ones that we're going to explore are alarms and obviously logs. The other ones, which include metrics, dashboards, events, contributor insights, and synthetics, we did not use any of them in this tutorial series. Back to alarms and logs, you are given 10 alarm metrics per month, 5 GB of log data ingestion per month, and 5 GB of log data archive storage per month, all for free. However, for all of these free tier offers, I'm not sure if it's per region or across all regions combined, so you may have to do more research on that on your own time. But once you have reached your free tier limits for the month, you start paying for these Cloudwatch services, starting with alarms. After 10 alarm metrics, you start paying a certain amount per month for each alarm metric you have in Cloudwatch, depending on the type of alarm. Now, you may be asking yourself, where in this tutorial series did we ever use alarms? And the answer is that when we made tables in Dynamodb in provision capacity mode, 8 Cloudwatch alarms were created by default for each table. So if I go to the Cloudwatch dashboard, specifically where it says alarms on the left side of the screen, you will notice that there are 24 alarms total, which makes sense because 3 tables times 8 alarms equals 24. And the reason for these Cloudwatch alarms is that, like we talked about before, Dynamodb by default already sends capacity metric data to Cloudwatch, but once a table's current consumed capacity for reading or writing exceeds the target utilization percentage of the current provision capacity, or drops below 20% below the target utilization percentage of the current provision capacity for some time, a Cloudwatch alarm will get invoked so that auto scaling can be triggered for the Dynamodb table, whether its provision capacity needs to scale up or scale down. And I didn't mention this when we were talking about Amazon SNS pricing, but when the alarm is triggered, a message can typically be sent to an SNS topic. By default, when you create a table in Dynamodb in provision mode for the first time, an SNS topic is automatically made for that purpose. So from time to time, you may be billed for SNS publish requests for Dynamodb Cloudwatch alarms, but in this tutorial, we don't have anything subscribed to that topic, which by default is named Dynamodb. Going back to pricing, since we have 24 alarms, each of which are of standard resolution by default, we will not be charged for 10 of those alarms since they will be covered under the free tier, but we will be charged for the other 14 alarms 10 cents each since they are all in the US East North Virginia region, totaling $1.40 for every month that those alarms exist. And they will usually exist as long as those tables in provision capacity mode exist as well. Although you can technically delete those alarms, I would highly advise against doing so if you are still using those tables in provision mode. Otherwise, you risk disabling the ability of those tables to auto scale up or down their provision capacities. And for those who are curious, the difference between standard resolution and high resolution alarms is that high resolution alarms check metrics more often than how often standard resolution alarms check metrics. Moving on to logs, we ingest quite a bit of log data each month, primarily from Lambda functions. So as you can see from this chart down here, in the US East North Virginia region, you are charged 50 cents per gigabyte of log data collected/ingested beyond the free tier of 5 gigabytes per month. Now, luckily, there are no data transfer in costs for Cloudwatch. So this 50 cents per gigabyte metric is the only cost metric when it comes to data ingestion. So if this month in the US East North Virginia region, let's say we collected 7 gigabytes worth of logs, the first 5 gigabytes would be free of charge, and then we would be billed $1 total for the other 2 gigabytes. Right below the data ingestion costs are the data storage costs. So when logs are collected by Cloudwatch, they get archived in Cloudwatch until you manually delete them. That's how we are always able to go back to Cloudwatch, sift and filter through log groups and log streams, and find specific logs that we want to examine. However, this costs money. Luckily, with the free tier, the first 5 GB of storage per month is free, and then you are charged 3 cents per gigabyte stored after the first 5 GB every month. So if you find yourself ever getting charged a lot for log data storage, then try to reduce the amount of log data that you are collecting, or reduce the amount of log data that you are archiving by manually deleting some log streams or even some log groups. And as for the last entry in this table, we don't analyze our logs in this tutorial. Also, there are data transfer out costs associated with Cloudwatch logs, but we never transferred our logs out of Cloudwatch in this tutorial. And further below, we don't use vended logs in this tutorial either. And below this overall pricing table, you have a bunch of pricing examples for all of the Cloudwatch services, as well as a pricing calculator and additional pricing resources. And that is pretty much it for not only the pricing details of all the AWS services covered in this tutorial series, but also that concludes this tutorial series. Thank you so much for sticking around until the end. I hope all of you learned a lot, and I really appreciate everyone who took the time to watch these videos, share feedback, and show support. Special shout out to our higher tiered patrons on Patreon, which include SolarTrix, Keith Perry, Caron Tatum, BioBlaze Payne, Diego Eduardo Camacho, Elise, and Max Norris. Links to our Patreon, PayPal, GitHub sponsors page, and our other social media profiles are in the description below. Please like, comment, and subscribe, and I hope to see you in the next tutorial series, whatever that will be about and whenever that will come out. See you soon and take care.